This Zoom session is being brought to you by the fractal picture of itself. We proceed. So, for today, we are going on about circles and graphs. An equation of the form y equals f of x has a graph which consists of all the points x by f of x, basically points x, y, where y equals f of x in the Cartesian plane. Now, often what we'll do is we'll given an equation, we'll write a table of values, and from that derive some points and draw the graph between those points. So, for example, the equation y equals x squared, we'll let x go from -2 to 2. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Plot all those points, 2 by 4, 1 by 1, 0 by 0, -1 by 1, and 2 by 4. That's only 5 points on a line with a continuum of points. So this is necessarily something of an approximation. So, but you draw a smooth curve as you can between them, and it works in this case. If you have a graphing calculator, it'll do the same thing, only it'll find the coordinates of thousands of points before it plots them. Here we have an equation 2x plus 3y equals 6. Now this is of a form called linear. Its graph is a straight line. In this particular case, we'll do a trick called the intercepts. For example, the y-intercept is where x equals 0 here. And if we plug x equal to 0 in here, then we get the equation 3y equals 6 or y equals 2. So we plot the point 0 by 2. Just a second. So this. Whereas, okay, and the x-intercept is where the line, where the graph meets the x-axis, where y equals 0. Plug y equals 0 into this equation, you get 2x equals 6 or x equals 3. So here's the point 3 by 0. You plot 0 by 2, 3 by 0, draw the line between them, and that's the graph of this equation. And there will be other equations, plenty of them, other graphs. Graph of y equals sine x, y equals cosine x, y equals tangent x, and on and on and on. All right. Now, a plane has symmetries. You can flip it through the y-axis. That turns the point xy into the point -x by y. You can flip through the x-axis, which turns the point xy to the point x by -y. And you could do both. You could flip, so you could flip left to right, then up to down. That's the same thing as rotating 180 degrees through the origin. And so, okay, and that takes the point x by y and turns it into the point -x by -y. So they have some examples. Find a point symmetric to -2 by 1. Symmetric through the x-axis, flip y, -2 by -1. Symmetric to the y-axis, flip -2 to +2, 2 by 1. Symmetric around the origin, flip both, 2 by -1. You have the point 3 by -4, flip to the x-axis, that changes the y value, -3 by 4. Symmetric to -3 by -4 through the y-axis, flip the first value, 3 by -4. Symmetric around the origin, flip both, 3 by 4. So points, you have symmetrical points, and the graphs can be symmetrical. Here we have a graph which is symmetrical through the x-axis. You flip it up or down, it's the same graph. Flip this graph left for right, the same. Swap this graph around 180 degrees, that's the same. So this is symmetrical through the x-axis, which happens when you can change the x value to its opposite. This is symmetric, through y value to its opposite. This is symmetrical through y-axis when you change x value to its opposite. This is symmetrical around the origin if you flip each value into its opposite. Excuse me for a moment. All right. Graphs can have x and y intercepts. Here's a graph. The y-intercept is where it meets the y-axis here. That's when x equals 0. So you set x equals 0 into the equation, solve for y. The x-intercept here and here is where y equals 0. That's there you can solve. Set y equal to 0 and solve that equation for x. Here we have a graph. Its y-intercept is 2. Its x-intercepts are -4, -2, 2, and 4. And in this case, it appears to be symmetrical through the y-axis. So change x for -x. You also get a point on the plane. on the graph. Now, this is a trigonometry course, but really it should be called a cyclotometry course, measurement of circles rather than just triangles, because circles are really how usually the trig functions work. So anyhow, the question is equations for a circle. So here's a circle. It has a center h pi k. It has a radius r. And the question is, what's the equation for x and y on this circle? Center hk, radius I, what equation? Well, the distance from xy to hk is r. Well, okay, by the distance formula, that means the square root of a sum of the squares of x minus h and y minus k. So root sum x minus h squared plus y minus k squared equals r. Usually we square both sides to put it in this form. X minus h quantity squared plus y minus k quantity squared equals r squared. That is
question.
Yes. Please.
What does k represent?
K is the y coordinate of the center.
Okay, it's just arbitrarily named k, or?
Well, I'm just using those.
Oh, okay, gotcha. Okay.
Sometimes the book uses x naught and y naught, which I don't really like because it makes them look too much like variables.
Gotcha. Okay.
Sure. I did a similar thing. We're talking about a line through h pi k with slope s, and a y minus k equals s times x minus h, whatever. Okay, so for example, circle with center -2 by 7 and radius 5. What's the equation? All right, here we go. X minus -2 squared plus y minus 7 squared equals 5 squared. Now minus and negative is a plus, so you get this. X plus 2 squared plus y minus 7 squared equals 25. This plus for a negative value for the coordinate is a trickiness you should watch out for. And remember, this is an r squared on this side and not r. So here's some examples. What is an equation for the circle with center 4 by -3 and radius 5? Okay, x minus 4 plus y minus -3 squared equals 5 squared. That's x minus 4 squared plus y plus 3 squared equals 25. This is called the standard form. You can read off the center and the radius. Then if you expand this out, x minus 4 squared is x squared minus 8x plus 16. Y plus 3 squared is y squared plus 6y plus 9. Fine, equals 25. Then after a little bit of simplification, you get this. X squared minus 8x plus y squared plus 6y equals 0. This is called the general form. What center, radius, and intercepts for the circle with equation 2 times x minus 3 squared plus 2 times y squared equals 8? Well, okay, first of all, these 2's are annoying. They're in the way. So let's divide them out. Y minus 3 squared, x minus 3 squared, excuse me, plus y squared equals 4, and that 4 is 2 squared. So you can read off the center, 3 by 0. The radius is 2.
I have a question.
Please, yes.
So for this standard form equation, it's x minus y squared. And then you have
x minus h squared.
Yeah, you have x. Oh wait, sorry, it's down. Yeah.
Down?
You have x squared minus 8x. Where did the 16 come from? And the 9.
Oh, this. When you expand, if you expand a minus b squared, it's a squared minus 2ab plus b squared. It comes from squaring 4.
So you're squaring it twice. You have the 8x.
So here you have a binomial, 2 terms squared. That'll be the form x squared plus 2ax plus a squared. In this case, it's minus 2ax plus a squared.
Okay, thank you.
That's expanding a binomial. That's fine. So all right, now there's a question. So here's the center and radius. For the intercepts, well, for the y-intercept, we said x equal to 0. So you get 9 squared. Because we put on 0 here, you get 9 squared plus y squared equals 4. So y squared is -5. No real solution. So no real y-intercept. For the x-intercept, we set y equal to 0. You get x minus 3 squared equals 2 squared. Taking square roots, x minus 3 is plus and minus 2. Add 3 to both sides. So x is 3 plus and minus 2. So x is 5 or x is 1. Those are 2 x-intercepts. So, okay, the circle can sometimes meet a line not at all, or twice, or in an extreme case, once. Find the equation of a circle with a diameter ending at 1/4 and -3/2. Let's imagine this. We have 0.1/4, -3/2. We need the center and the radius. Since this is a diameter, the center is the midpoint of this diameter. So we take the midpoint between 1/4 and -3, 2, -3 plus 1/2, 2 plus 4/2, which, bit of arithmetic, -1/3. Okay, there's your center. Now, for the radius, okay, let's take the distance between this center, -1/3, and the point 1/4. That'll do. 1/4, -1/3. So square root of sum of squares of 1 minus -1 and 4 minus 3. That comes out to root of 2 squared plus 1 squared, which is root of 4 plus 1, which is root 5. So center is -1/3, radius is root 5. So the equation is x minus -1, that's squared, plus y minus 3, that's squared, equals root 5 squared. Just a second. Okay, and the minus and negative is a plus, root 5 squared is a 5. So here we go. X plus 1 all squared plus y minus 3 all squared equals 5. And again, here, watch out. We have this on this side is an r squared, not an r. In this case, r is root 5. Here we have a 5. So don't confuse the two. Here, well, okay, here we have a circle with a radius with the equation x squared plus y squared equals 9. We draw a square inside that. It has to find the area of this square. This is really a case for geometric more than algebraic reasoning, but why not? X squared plus y squared equals 9. That's 3 squared. So it has, the circle has radius 3. So each of these diagonals is length 3. Now, here I do what's called a dissection. We have this square with these 4 half diagonals equal to 3. We break it up into these 4 pieces. We reassemble it into 2 squares, each of which has side 3. So this side area has side 3 squared. This area has, the square has area 3 squared. So the total area of this original square here is a sum, twice 3 squared, twice 9, 18. And that's similar to a problem in the book. Okay, well, I believe that we have done our work for today. Let's close it off.